Remember arc length? Arc length was this nasty formula. Remember that guy?
Yes.
And remember how he was, oh, what? The Sam Hill just happened. Remember how disgusting that was? It never integrated nicely unless it was some lame function. Mm-hmm. Well, this surface area is very similar.
Oh, awesome. Right?
You're welcome.
I love how you open up. Remember that stuff that nobody wanted to do?
But,
More of it.
but, you like, so first of all, probably going to be a double integral, because it is. It's going to be a square root again, but it's going to be 1 plus dy dx, or sorry, not dy dx, dz dx, stupid, try again, squared, plus dz dy squared dA, right? And it is going to be just, well, kind of gross. But life goes on.
Could have been worse. Could have been DZDU.
Yeah, could have been. Still could be, I guess. But yeah, there it is. So it looks not that bad. It's gross. It's just going to be gross because we need a function. So suppose we had a function z equals, I don't know. I feel like I use the same functions every time, but I don't really care.
3x squared y, is that what you're going to write?
No.
I
Screw
was
you.
thinking, what am I going to write?
Screw you.
Oh, darn.
There, I fooled you. All right, I don't care. There, I don't even care. What happens? So dz dx would be 3 plus 2y squared plus y. dz dy would be equal to 4yx plus x. Right? And if I want to integrate it over the region from 0 to 2 and 0 to 4, my totes can do that. So I'm going to do the double integral of the square root of 1 plus this thing plus this thing. Either order you want, doesn't matter. I chose this direction, but you can do whatever you like. All right. Now, one could see like, oh, I know, let's FOIL it out and do substitution. You're an idiot. No. So, I'll try it on my calculator up here. So, what's probably going to happen is your calculator is going to say, I give up, I'm not doing it.
Your calculator didn't spend 1 minute working.
No, it'll work like an hour. Yeah. So, and then I'll show you that if you use this emulator, you can speed it up, of course, and it'll probably get there, but it's probably still going to have a long time to think about it. And so what we're going to end up doing is doing some integration by numerical methods today in Excel, which is kind of why I bring it up the day of this, because, well, you need something different. We'll give it about a minute, and I'll break it and hit it in the overdrive mode. Okay, I'm bored of this. So, on, don't forget on is how you break it. So otherwise you don't get stuck in this infinite loop thing, whatever, forever. Oops.
No calculator. The answer is error break.
Yeah. Unrestricted. Did I unrestrict it? I can't tell if I actually got it or not. Unrestrict. There we go. Go.
So is it going as fast as it possibly can?
It's going as fast as this processor and the computer goes.
Oh, okay.
Oh,
Okay?
well, that's
149.926, and it literally shuts off. Because now the clock also runs that fast. So it thinks it's been on for 20 minutes, and so it shuts off. So, surface. So the surface area is 149.9. 149.9. And that's great, but we're going to use Excel to do this instead. Okay? So, the key when we do this Excel business is this. What did I say, 0 to 4 on the X?
Yeah.
Is that what I said?
0 to 4 to Y.
yeah, 0 to 2.
Oh, 0 to 2 on the X. 0 to
I got
4.
it. I got the answer.
Eventually, yes.
Mine's still going.
Now,
That wasn't bad.
Okay. So, a person could do this. And what you could do then is find this midpoint. And the idea is very similar to what we did with midpoint rule back in the day. But basically you're going to be building one of these dudes. Yes?
Yes.
And so it's the midpoint it's going to be f of the midpoint. So it's going to be the heights of each one of these fellers. And then your dA is the dx and the dy, right? Okay? Or the delta x and delta y. So when we play this game, just keep that in mind. So here, this would be, for instance, well, this would be, 0 plus the half of the delta x, right? Comma,
Oh, it doesn't say critical.
comma, 0 plus half of the delta y, right? Right? That's where that middle point would be. And then, so the next one up would be what? Well, the x's aren't changing, so these are all the same x's going up. These are all the same y. Well, these all have the same, the y's would stay the same going this way, yes? So in essence, that's what we're going to do. And so then, of course, you're going to find the z at this value. So z of that value, z of this value, z of that value. Add them all up, and then multiply by the dA, yes? So, in this case, let's use 100 boxes this way,
Oh, and then are you gonna do it?
and 100 boxes this way. So that's 0.04 this way, and 0.02 this way. Oh, you whore. 0.02 this direction as well, yes? So my dA then would be 0.0008, yes? When it's all said and done. So each one of these boxes has, well, there's a bunch, there's not just this giant box. But each of those boxes would have a dA, an area of 0.0008. So then times those by their heights, and then you know their volumes. Okay? So in Excel, what I'm going to do is same basic situation, except I'm going to start here. And I'm just going to say, I like to just start off with, all right, well, in my mind I just go 0 plus, and then this is the x's, so then it's delta x over 2, which is that 0.02 divided by 2, right? So then this guy here is this guy, that, I said that guy, plus the delta x, which is 0.02, yes? And then just drag it across. And as we mentioned last time, if I go over 100, that is CW. Don't laugh, that may come in handy on a game show someday. Or, hypothetically, you're playing a game with Levi's brother, who you didn't even want to play the game anyways, because it's kind of a dumb game. And Ford cajoles you into playing, so you're playing it. And then, just when you're about ready to say, I'm done, this answer can come up. Something like this. Or in my case, it was, how many square feet are in an acre? I win. Bro, how do you know that? Well, it's just one of them things you learn, right? So 0.04 divided by 2. And what? That's 23. Try again. There we go. And then equals this fella plus 0.04.
Did you just decide that was the delta x?
Well, I decided. The book won't tell you. Okay? So I'm picking a delta x that makes me happy. And I feel like that's probably close enough. Now, in a few minutes, we'll see exactly how close we are, because this one we actually could do. But then we'll always be able to do them. Okay? So you can always go bigger. One time, I did 1,000 by 1,000. By the way, that's 1,000,000 boxes. Excel took quite a while to think about that. And when it spit out the answer, I was good out to, I forget how many zillion decimal places we were good to. So it's quite a ways. So equals the squirt of 1 plus, and what is it now? What's our function inside? What's our derivative?
3 plus 2y
So
squared.
3, wait a minute, 3 plus 2 times y, get the fn,
Y squared.
and I want to keep that in a, right? Did I say y? Is it y squared?
That's y squared.
Y squared. And then what?
Plus y.
Plus y.
And then that will be
Oh, fart, what happened? Plus y, and then we'll fn a couple more times. There we go. Squared plus
4yx
4 times y times x
plus x
plus x. Oops. Bam! Right? Give one of these, double tap it again. Whee! And then clear to the bottom. Grab this thing here, take off running with it. Boom. Nice. So we're going to equal the sum of, what did we say? That was B2, is that right? To CW101. Bam. Times 0.1238. Yes? Bam. So again, your calculator will often tell you to take a flying leap if it's something interesting at all. Okay, I mean, like the ones from your project, like, this is like a good project. Okay, well, maybe it is, maybe it isn't. And you go to do the math, the computer probably will not be happy with you. But Excel will always do the work for you. It's not a problem. All right, let's do another one. Okay, so, how much? 0013? How close do you think we are here? I could have added more decimals. Here, let's go put decimals back on my calculator. On
Well, that's gonna make it worse.
emulator, restrict. Wait, no, we're not, because I got to get this in the float. I'm just going to straight up float it. Oh, now I got to hit the calculator. Oh, stop. Escape. Unrestrict. Come on, Betsy. Maybe I didn't hit. Oh, there it goes. Nice. 0.926. So we're off by 3 ish. 2.4 thousandths we're off by. Whoopee! Out of 149. I'll live with that. I'll live with that for plutonium probably. I bet we're pretty good probably. Okay. All right. So another one. Let's suppose our function was f of x and y equals the cosine of x plus y minus 3x sine y plus x. So, the partial with respect to x. I can't do that in my head. Well, I probably could, but I don't care to. So, the derivative of the cosine of x plus y minus 3x times the sine of y plus x, comma x, negative sine x plus y. Hi. How are you? Thanks, man.
It's 52, right?
It is. Lazy. What? What'd you say? Right? That should be the other one, I think. So you might want to do it from 0 to 3 and from pi over 2 to 3 pi over 2. Well, that's not true. I don't want to do 3 pi over 2 because I don't want to do the knitting. I mean, I can do it in the calculator, but in Excel I don't want to. Let's go 6 to 8 because I don't care. Okay, makes no difference to me. It seems pretty random. Everything about what we do is random in this class, so whatever. Okay, so double integral. Double integral. We're going to integrate the square root of 1 plus parentheses. It's going to be negative sine x plus y minus 3 sine y plus 1 squared plus negative sine x plus y minus 3x times the sine of y. Comma x, comma 0. It is. Thank you. God dang it. Way to go. Maybe you catch me a little quicker next time. Maybe. Now, by the way, this midpoint thing that I teach you is not the only way to do numericals. In fact, there's a bazillion ways to do them because the person could use the lower left-hand corner of each of those, the upper rights, all that good stuff. There's literally, you could take classes on just numerical integrations in multiple dimensions. It doesn't sound fun. It's not interesting at all. I just want to get a general gist of it. Thank you very much. The midpoint actually does a fairly decent job. I will not tell you it's the best. It just happens to work fairly well, and it gives us the gist of what I want to talk about, which is, that's just all that matters in this case to me. Notice that this is unrestricted speed here, and it's still taking a sweet long time, which doesn't really shock me at all, because this is a nasty problem. It's got this cosines and crap in it. It's, yeah, wow. So while this is doing that, let's go play in Excel instead. It's fine. It'll get done, and then it'll shut off, and we'll be happy about that. Now, what was for our x? We were going from where to where?
0 to 3.
So, pick the numbers. What do you want to count by? 100? You want to do a delta x of 100? You want to do 200? I mean, I'm sorry, not delta x of 100. I mean an x. You want to do 100 boxes. 100 boxes. All right. So then I'm going to equal 0 plus 0.03 divided by 2. That's the first midpoint. And then, of course, equals this guy plus 0.03 for our delta x. Done. Cool. And this one over here, we went from where? 6 to 8? 6 plus, and then, so that's 0.02, so plus 0.01. Well, whatever.
That works.
Equals, sometimes I'm amazed what it'll chew on. You wouldn't think it'd be a problem, but whatever.
How many boxes do you use?
I did 100 by 100 again. Kind of lame. No, not really. It just takes too long. It's hard without a mouse. All right, so equals. What? Yeah, I don't know that one. 1 plus, what was it? Sine, negative sine of x plus y. Then what?
-3 sine y.
Is there a way to define what x is and what y is?
Hmm.
Like define it as a variable. Could you be like, x is $$sign y?
But it's only true for that cell. I want to be able to just type it in once and then just drag it down, drag it over.
There is a way to do that.
You
have to
could,
go
it's-
to code and then write some digital basic.
Oh, right, because then it would think that it would always be $$sign y.
Yeah.
Mhm. Is that all?
Plus one.
Oh, plus 1. And then plus, you can actually do it without the Visual Basic. You can do it a different way, but it's just, yeah, it's just, you don't want to do that. You just want to pin it down for that one and then drag it. What else?
Negative sign.
Negative sign.
I was thinking about it purely as an easy way to type it in.
Yeah.
But you only have to do it once, so it's not horrible. Plus y. From time to time, you'll see me actually type y because I'm an idiot not paying attention to stuff. Then what?
-3x.
Okay, I think I'm gonna have to go home sick pretty quick. I ate a donut, and then Richard gave me another one, and I ate that too. I know, it's disturbing. I have to go stick my finger down my throat. There we go. No, I was telling you, that's what I feel like I need to do. There it is. No, I'm saying I think they have it figured out, yeah. That's what I was thinking. No!
Oh, wait, there might be a way to do it. I was trying to think of a way that you can autofill sign.
Yeah.
Look at the options button down there, and there might be an option to autofill it on there.
I'll be trying to calculate this on the calculator with busyness part.
Yeah. Just a moment.
So the little tab that pops up.
Yeah.
and then you autofill sign it.
I don't know. I can't see it.
I was trying to do that.
Oh, nailed it.
Nailed it.
Lucky shot.
All right, so equals sum B2 to CW 101 times our delta X was 0.02, right? One of them was? And one of them was 103. 24.9. Is that what it got?
I don't know.
Mine's still going.
Anyway, I'm pretty sure it will not get around to finding it. It may or may not, but it probably. Oh, I under 60 mine. Let's look at it. Oh, yeah.
Okay.
Nice. Nice. So, that's how I want you to do it. Most of the surface area ones, of course, the ones in the book, probably the calculator will eat up fine. Probably. However, you will do the one for your project, probably will not. So, do it this way. Okay? You're like, but can I just do regular double integrals this way too? Yes, Dono, you sure can. You sure could. So, Dono, if you ever get stuck, you're like, "Ah, I can't remember how to do this. I can't remember typing in my calculator. Okay, well, whatever, weirdo. You want to do it in Excel, go right ahead. You totally can. Now, I was going to show you one more thing here. Well, I have all these numbers up. Go, 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 go. Go. There we go. Bam. I think I showed you the conditional formatting, right?
Oh, yeah.
Ooh. Interesting.
Look, you can see the line.
You can see the topo, the contour maps, in essence, yes? Where green is what? I don't know, but you can probably figure it out. Positives. Whoa, I really pissed her off this time. I'm sorry! I'm sorry, Betsy. Well, I really pissed her off now. Oh, there we go. And of course, these fellers are the uh-oh. These fellers are the smaller ones, yeah? But whatever. Okay, I don't know, whatever. Kind of cool. I think that was. Yeah, I don't know. So that's surface area. And I swear I give it to you on a, where's the homework? Yeah, you know I didn't. So, I just looked it up because I was like, I knew I was missing something. So, it's on page, can I borrow this again? Thanks, man. It's on page 900 and, you're like, why is it there? I don't know, it just is. That's also where the Jacobian is. It's back in that chapter too, but I don't really care. We'll get to that this pretty soon too. 920 something. I was just looking at it. 9. God, where'd it go? I just saw it. Surface area 979, dummy. 979-ish is where it starts. And the homework is on like page, there we go. Let's do these. I don't know how I didn't get all your homework written down for this, but something's screwy. Okay, where is surface area? Perhaps I'm just going to have to make a worksheet for you. Yeah, I mean, that's what I'll do.
She's still working
On the slash problem?
for it. Yeah.
Yeah, I think I'll just make a worksheet for you.
But, yeah,
Anyway, I'll make a worksheet for you on it. But I didn't add it to the homework page, so I guess I'll get that done. Yeah. All right, close that. So your calculator's still done? It still
It's
isn't?
still working, but Jacob was gonna look at it and he picked it up, button side down, and I was like, you probably just